Hello everyone, welcome to Spring Security Series. My name is Vishal Kotecha and today we are going to talk about JWT. What is JWT and why should we use it? The best place to learn JWT is its official website, jwt.io. When we open this website, it gives the standard definition of JWT. And if you are learning JWT for the first time, this definition can be a bit confusing. So let's try to break it down into three parts and understand what is JWT exactly. The introduction tab of this website is a bit more useful. It says that it's open standard, it's a compact and self-contained way for securely transmitting information between parties as JSON object. Now let's keep aside this open standard part because we understand it's open standard and there is a specification written for this JWT. But we are interested in the other three parts. It's a compact and self-contained way, means it's compact and it contains the information within itself. It is used to securely transmit information between parties, means JWT is something which contains some information which can be securely transmitted. In which form? The answer is here, in the form of the JSON object. Further, it says that this information can be verified and trusted because it is digitally signed. So from this we can translate what is JWT in plain English like this. JWT is nothing but something which carries some information which can be transmitted securely because it is digitally signed. And how it is secure, further it talks about the algorithms which are used in the JWT, which are basically HMAC, RSA or ECDSA. Now the HMAC is a symmetric one and RSA and ECDSA are a symmetric one. We are going to talk about them in a minute. Let's see when we should use the JWT ideally. So the website says we should use JWT in two scenarios: authorization and information exchange. The authorization one is the most common one because here what happens is once the user logs in, he gets the JWT and then the same JWT needs to be included in all the subsequent requests in order to access the resources. So that's how the authorization is achieved using JWT. The next is information exchange. Because the JWTs are secure in terms of digital signature, they can be easily used to information exchange between sender and receiver. And if JWT is changed, even a single character, so it won't be the same JWT that was earlier. So it means that we cannot tamper JWT because then it will be a different JWT at all. So now that we know what is JWT and when we should use it, let's see how does it look like. So on the left hand side, this is the encoded version of JWT and this is how it looks like in the real world. So you can see that there are three parts, 1, 2 and 3. They are separated by dots. The first part is base 64 encoded version of header and this is the decoded part of it. So if you change anything here, it will be reflected here. If you change anything here, it will be reflected over here. It's vice versa. You can see that the first part is the header. The header contains metadata like which algorithm is used and what is the type of the JWT. Here the algorithm is HS256, meaning the HMAC algorithm is used along with the cryptographic function SHA256. Now this is symmetric, so it uses just single key to encrypt and decrypt. The other algorithms like RSA and ESDSA, they will be asymmetric, meaning they will require to generate public and private key for encryption and decryption. Now here the second part is payload, which is this part. So This part is very important because this is where we are going to store the information. So when we saw the definition that JWT is nothing but something which carries some information, so this is the information that requires to be transmitted securely. Now here there are some keys like subject, name, IAT meaning issued at. So it is the time, date and time here. Similarly, there can be more parameters like when does this expire, what is the audience for this JWT, etc. So it is clear that because this JWT can be decoded with this tool right away, we should not put any secure uh, properties, secure information like passwords or something like that in this one. This is just for authorization purpose. The third part in the blue one, it says that this is for verifying signature. It contains the base64 version of the header plus this dot base64 version of this payload, and it requires some secret key. So we have to choose a secret key which is difficult to be guessed, and that way the JWT is secure. So now that we know what is JWT, when should we use it, and how does it look like, now let's see why we should use it. In the previous video, we saw that Spring Security uses cookie-based authorization by default. So when a user made request to login, not only server responded with successful response, but it also created a cookie. Now this cookie, browser understands how to store it and how to send the cookie into the next requests. So when we made the next request to get list of products, we got the list of products from the server because from the cookie, server was able to authorize the user, and this is how the cookie looked like. The question is, why do we need even these mechanisms like a cookie or a token like JWT? The answer is the browser or a client and the server speaks a common language, which is HTTP protocol. This HTTP protocol is stateless, means it does not remember anything. So it is client's responsibility, and when I say client, it can be a browser, it can be a mobile app, it can be anything else. So it's client's responsibility to present something using which server can authorize the request. Now this something can be this cookie in terms of JSession ID, or it can be a token like JWT. So because of this nature, the cookie-based authorization is also known as session tokens or the reference tokens as well, because the cookie has some random string which refers to some session. Now let's talk about the upsides and the limitations. The cookie-based authorization is supported by most of the frameworks in many programming languages. Because the cookie is understood by the browser and the browser knows what to do with the cookie, there is no need to handle client-side code. Now it is possible for any hacker to run some JavaScript code in the browser's console and retrieve some information. But if we are using cookie-based authorization, and if the cookie is marked as HTTP only, it is immune to the XSS attack, which is cross-site scripting attack. So basically, the HTTP only cookie cannot be accessed by the XSS attack. It is secure that way. Coming to the limitations, there are major limitations in the cookie-based authorization, like only single domain is supported. So from the domain the cookie is created, it is supported and it is sent to that only particular domain. So when we have a architecture like microservice based, it could be a problem because there we are dealing with multiple domains. Also the major problem comes with the scaling part, especially the horizontal scaling. So when we have deployed our instance and when we want to perform scaling, at that time the session ID is created from one instance cannot be recognized by another. So at that time we have to store these session IDs at some place like Redis or MySQL or PostgreSQL databases. So which becomes a bit difficult to handle the sessions and the IDs accordingly. And when we are using the load balancer will certainly not know to which instance should I forward this request. So there is a workaround against this situation, and the workaround is to use something called a sticky session, where the load balancer has to remember to which instance the request should be forwarded to. CSRF or cross-site request forgery attack involves something in which a third party makes a request on behalf of the user. So the best example of this is when you are logged into net banking, and while you are logged in, you access some link or some web page which has the malicious code, and they can make a request on behalf of you to transfer funds from your account to theirs. So if we are using cookie based authorization, it is very likely that the cookies are being sent to the server by default and we cannot prevent it unless we are using some additional tokens to prevent CSRF. Now the other one is that the cookies are being sent to the server by default even when we do not need. So basically if you want to access some resources which are publicly accessible, like some default static pages, some images, some resources like CSS and everything, so at those times cookies are being sent as well. Coming back to the cherryability part, so what kind of conversation happens between the client and the server when it's cherryability? So this time the login request is made using email and password. The server responds with a successful response. This time the server generates a token. Now the browser do not understand what to do with this token, so it is up to the developer to store and to manage this cherryability or this token, because browser only understands how to deal with the cookies, not anything else. So next time when we made request to, let's say, get list of products, server does not understand the request and it asks for the authorization part. So when you when the client provides the token along with the request, server understands and it provides a list of products. This time the token looks like this. So it has some metadata, the payload, and it is digitally signed. So basically you can think of this JWT token as some ID card which employees carry with them. So this ID card usually has some photograph, some first name, last name, email, and blood group maybe. It does not contain any sensitive information. So this ID, using this ID card, they can enter and exit from the company's premises. So this is exactly what a JWT would look like. And when we talk about cookie-based authorization or session tokens, so those are basically, we can say that we are carrying just employee ID with us, and every time we are presenting just the ID, and now it's up to the server to make a lookup from that ID and verify that it's really the user who is making the request. So now upsides or the advantages of this JWT based authorization is now the CSRF is prevented. We are because the tokens are not sent to the server by default. JWT is supported with multiple domains as well, and we can send the JWT whenever we need it. It is very easy to use a token based mechanism like JWT to access in mobile application and web application. There are some limitations of JWT as well. It is not silver bullet either. So basically developer needs to store and manage the JWT. If it's not stored properly, it XSS attack can retrieve the JWT and steal the token. Now, when such scenario happens, it is not possible from server side to expire or invalidate token unless and until we store the token and mark them as blacklisted tokens and perform validations accordingly. But this again defeats the purpose of having stateless communication, because again we are storing the token and it is not stateless anymore, it is stateful. So basically the cookie based authorization or session tokens can be understood as stateful communication, and the JWT based authorization or web token based communication can be understood as stateless one. So even though JWT has its own limitations and many developers have their own perspective, they still tend to use the cookie based authorization, but the JWT is widely used, very popular mechanism. And yep, that's all about the JWT based authorization today. In the next video we will integrate the JWT to our Spring Security application. So stay tuned. Thank you for watching.